Welcome. Today's little video we're talking about empirical formula and what that means in chemistry. So just a couple of quick tidbits here on empirical formula. When you're looking at a chemical formula, all of the elements and atoms that make up that chemical formula, if the subscripts are in the lowest reduced terms, that's going to be the empirical formula, right? So the empirical formula expresses atom-to-atom molar ratios in their simplest, lowest reduced numbers here. Empirical formula can be calculated from the percent composition of a compound. So in other words, if you know the percent composition by mass of each element in a compound, you can figure out empirical formula. Some examples of empirical formulas, right? CH2O. I know this is empirical because it's a 1 carbon to 2 hydrogen to 1 mole oxygen ratio. 2 to 1 is the lowest reduced terms. Okay? Cr2O3. Once again, the 2 and the 3 are as reduced as they can possibly be. So it's got to be empirical. H2O1. For every 2 moles of hydrogen reacts with 1 mole of oxygen, it's going to be empirical. This, however, H2O4, would not be empirical, right? Because I can reduce the 2 and the 4 to 1 and 2. So this would not be an empirical. All right, so the steps. How do I solve for empiricals if I'm given a problem in class or for homework? Here are the steps. First thing you're going to do is always assume you have a 100 gram sample, because that's going to make the numbers work and be nice and easy. Because all you have to do is, if you assume you have a 100 gram sample, all of your percent compositions become grams from percentages. Find the percent composition, if it's not given to you, it usually is, of each element in the substance. That's going to tell you how many grams of that element you have per 100 grams. Convert the grams of each element from number 2 to moles using molar mass. So once you know how many moles of each element you have, you're going to compare each element mole to mole and divide your number of mole values by the lowest or smallest mole amount. The reason why we do that, you're going to get whole number ratios in the most reduced terms. And step E here is sort of a tidbit here. You don't always have to do it in problems. Let's say you get molar ratios that are not perfect numbers, 1.5, 2.3, okay, not whole numbers. You're going to multiply decimals by a factor that gets you back to a whole number. And I'm going to show you an example of that in the next couple of problems here. All right. So for example, let's use these rules. Practice problem. What's the empirical formula of a compound containing 68.4% chromium and 31.6% oxygen? I like this problem because we don't have to calculate the percent composition. They give it to us. All right? So they want to know chromium and oxygen. How do they react mole to mole? What's their ratio? Okay? So here's what we're going to do. Let's assume we have 100 grams. Because that makes things nice and easy. If we assume we have 100 grams, and this compound is 68.4% chromium, if you have 100 grams, that means you're going to have 68.4 grams of chromium, and the percentage of oxygen changes simply to grams. We don't need a 100 gram sample. It doesn't matter. But let's say that we do. It's going to make the numbers work in our favor. Okay. Part B, let's take the gram amounts of each element, in this case chromium and oxygen, and let's get those to moles, right? Because formulas are given on mole-to-mole ratios, not gram-to-gram ratios. So I take my 68.4 grams of chromium, I multiply that by the molar mass of chromium, right, for my periodic table, which is 52.0 grams, and I get this number here, 1.315 moles of chromium. I'm getting lazy on this slide. I'm not using sig figs for those folks who are particular about sig figs. Okay. I've got 31.6 grams of oxygen divided by the molar mass, which is 16 grams of oxygen, and I get 1.975. I cannot keep it like this, right? They're not whole numbers. So what I'm going to do is I'm going to take the smaller of these two numbers, the 1.315, and I'm going to divide my mole values by the smallest. Now, once again, why do we do that? We can't leave this formula like this. This is weird, right? We don't write chemical formulas like this. But if I divide both moles by the lowest, this becomes 1. That's a nice number to work with. 1.975 divided by 1.315, that becomes a decimal. I can't leave it like this. This is a no-no. So how do I get that 1.5 to a whole number? Multiply by 2, right? Because 2 halves make a whole. So if I take CR1O1.5 and I multiply that by 2, I get CR2O3, and this is our answer. That's the empirical formula. Chromium reacts in a 2 moles to 3 moles of oxygen ratio. All right. We're going to have another video on these for some more practice on my webpage. I'll see you then, guys.